In this video, I'll show you guys how to solve this first-order linear differential equation. But as you know, we can do this by integrating factor. I will leave that to you guys because in this video, we see we have just constants, the 2, and then the negative 2 right here, right? So let me show you guys that we can also use the method of undetermined coefficient for this as well, even though it is just the first order, okay? So here we go. The first step is that I have to find the solution to the homogeneous case, right? That means the right-hand side is equal to 0, so we have to find xh. So to do that, let me just write this down again. We have to have 2x prime minus 2x equal to 0. And now let's change this into its characteristic equation. So this right here will be 2. The first derivative corresponds to r to the first power. And then minus 2x is just going to be minus 2, right? No r right here. And this is equal to 0. And you can see that r will be 1. And you know the homogeneous solution, xh, will be, the first building block will be e to the 1t, which is just t. And then you have to have one constant. So C1, we just need to have one constant because we are only talking about the first order, right? Now, we see we are going to do the second part, which is we are going to find the particular situation, yp. Well, for yp here, let's look at the right-hand side. We have a cosine t right here, right? And this is negative. But the main part is the function part. We have a cosine right here. Well, the trial solution that we're going to use is that not just cosine, but we also have to have the sine, okay? Let me just put down a, okay? And then we have the cosine t. And then we also have to have the sine, so put down plus b times sine t. The most important part is that the angle in the input, they have to match, t, t, and t. And another thing is that this right here, it is linearly independent than e to the t, function-wise, okay? So you see, this is e to the t and this is cosine sine, so they are linearly independent, so I don't have to do anything crazy. Be sure you put down the correct form for the trial solution for the yp. And now we can get to work. I just have to differentiate this one time. So yp prime, it will be, differentiate this, we get negative a sine t, and then differentiate that, we get plus b cosine t. And by the way, a small remark, if you want to say this is b cosine t and then plus a sine t, doesn't matter, because at the end, you have to find out what a and b are anyways. This is the method of undetermined coefficient. And you will find out what a and b are at the end plugged in. All right, now get to work. This right here is what we have to plug in for the first derivative. So as you can see, we'll have 2 times x prime, which is that. Let me put it on red, which is going to be negative a sine t plus b cosine t, right? Like this. And then we minus 2 times x, which is that. So we have 2 times a cosine t plus b sine t. Okay, and this is altogether equal to negative cosine t on the right-hand side. And now this is what we have. Well, as usual, we have to distribute and then combine the terms and then at the end match coefficients, right? So let's do that. And you know you have sine t terms and also cosine t term on the left-hand side. So let's see, let me just put down, I want to collect all the sine t terms first, okay? So let me put down sine t and then let me put down the rest in this parentheses. From here, I will have to do 2 times negative a. That will be the coefficient for the sine t in the first term. So I'll put down negative 2a right here. And the sine t is factored out already right here. From here, I will do this times that. That will give me negative 2b sine t. So it will be minus 2b right here. Okay? And I will combine this with, well, I don't know this is yet. This is going to be a cosine t term. And then I will write this down first, negative cosine t. Okay, for the first part, we have 2 times positive b, so this is 2b cosine t is right here already. And from here, I will do this times that, which is negative 2a cosine t, all right? And now we're just going to match coefficients. So as you can see, I put down the cosine t right here. This right here has to be the same as that, which is negative 1, right? So let me write this down. We must have 2b minus 2a equal to -1. That's the first condition. And the left-hand side here, we have the sine t term, right? That's a coefficient for that. But on the right-hand side, we don't have any sine t term, so it's technically 0 sine t, right? So this has to be 0. So let me put that down as well. We have -2a. Let me write it down. -2a, okay? -2a. And here we have -2b. I know the order is wrong, but you guys can handle this, so don't complain. This is equal to 0, okay? That's what we have to solve. Good, because this does not cancel right away, and then you see this is going to be -4a equals to -1, and a is equal to +1/4. And we can also find out what b is, right? If you plug in 1/4 into whichever equation that you want, let me just do it right here real quick for you guys. We will have -2b minus 2 times a, which is 1/4 right here, right? And this has to be equal to 0, and you see this is -2b equal to, this is still this times that, which is -1/2 equal to 0. Move this to the other side, you get -2b equal to +1/2. b is equal to -1/4. So that's what we have right here, okay? Anyways, we're done. Because at the end, you know, here's the third part. Final answer, x is equal to xh plus xp. So x as a function of time, this is equal to the homogeneous solution, which is that c1 e to the t. And for the particular solution, it's in this form, right? A cosine t, and the a is 1/4. So let me put that down. Plus 1/4 cosine t right here. And then b, which is -1/4. So let me put that down. Minus 1/4 sine t. And we are done right here. That's it.